Good day and welcome back, mga ka-learners! It's time for the part 2 of our lesson on types and causes of earthquakes. In part 1, we looked at the basics of plate tectonic theory to better understand where earthquakes come from. We learned that the Earth's crust is divided into plates and that it continues to move, albeit very, very slowly. Today, we will look at how we might see that movement for ourselves. We will also look at ways to measure how strong an earthquake is and where that earthquake occurred. Do you live in an area where there is a fault line? Are you familiar with what a fault is? Faults are areas on the crust where fractures are created by the motion of the plates. They are the ones that absorb the motion of the plates. This makes them the points where stress builds up. They are narrow zones which separate blocks of crust. One of the world's most well-known faults is the San Andreas Fault, which separates the Pacific Plate from the North American Plate. It goes through the cities of San Francisco and Los Angeles in California, and is the main reason why earthquakes are so common in these cities. Our country is home to many faults, referred to collectively as the Philippine Fault Zone. It is a 1,200-kilometer fault that starts at Bangi, Ilocos Norte and ends at Mati, Davao Oriental. Deep earthquakes can occur along this fault, especially in Luzon and Mindanao. Look at this map. You can see that the Philippines has plenty of fault zones, trenches, and troughs that are sites of active movements of the Earth's crust. By the way, a trough is an elongated depression in the Earth's crust that is bounded by faults. Faults resist the forces that try to move the plates apart. As these forces build up, the fault remains locked, which results in blocks of crust getting deformed due to stress. Eventually, the stresses get so high that the fault breaks in order to release the stress. Release of stress allows each side of the fault to slide past each other. This sliding motion is what we experience as an earthquake. Think of it like you would with a spring. When you compress the spring, you are putting stress on the coil and building energy. Once you release the spring, it bounces back and forth before settling to its original length. When an earthquake occurs, it pumps seismic waves into the surrounding rock. Seismic waves are the form in which energy released by the earthquake travels. These waves can travel all around the world and can be measured by an instrument called a seismograph. There are two basic kinds of seismic waves: body waves and surface waves. Body waves travel within the Earth. They travel outward in all directions from the focus, the particular spot where the fault began to break. Surface waves, on the other hand, travel only on the surface of the Earth. They travel parallel to the surface, similar to how ripples travel on the surface of a pond. They are also slower than body waves. Body waves strike first when an earthquake takes place. The fastest kind are the primary or P waves. They emit that train-like sound you hear just before you feel an earthquake. P waves can travel through gases, liquids, or solids. After the P waves, the secondary or S waves are the next to arrive. S waves are felt as a powerful jolt. Imagine a giant pounding his fist down on the roof if you were in a building during an earthquake. Afterwards, the surface waves strike. These cause the up and down and back and forth motions we often associate with earthquakes. They make the ground roll and topple buildings if the earthquake is strong enough. Locating earthquakes. Seismology is the study of earthquakes, their causes, as well as their effects. Seismologists, or people who study earthquakes, are able to locate an earthquake by examining the seismogram. a record of the shaking of the ground made by the seismograph. Through the seismogram, seismologists are able to determine the focus and the epicenter of the earthquake. Do you remember what the focus is? That's right. The focus is the specific spot on the fault from which the earthquake originates. The more commonly heard epicenter is the spot on the Earth's surface that is directly above the focus. To find out where the earthquake happened, seismologists look at the time difference between the arrival of P waves and the S waves. P waves travel almost twice as fast as S waves. Hence, they will arrive first at the seismological station. If you know the speed of the waves through the crust in a particular area, and you have a seismograph that records the arrival of the shocks, you will be able to compute the distance of the station from the focus of the earthquake. Get computations from 2 more stations for a total of 3. Draw a circle around each station. Look at where the circles intersect, and you can get the exact location of the focus of the earthquake. Predicting earthquakes. Do you think we can predict earthquakes the same way we can predict typhoons? Seismologists have been looking for ways of predicting when earthquakes will occur for years. While an accurate prediction is still far from our reach, seismologists have figured out warning signals that might help us in the future. Slight changes to the tilt of the Earth's surface can be detected by sensitive equipment. Geologists have also said that land near a fault may rise or sink slightly. Water level in wells will often go up or down when an earthquake is about to occur. These clues, however, are not enough. Scientists continue to study earthquakes in the hope of improving their ability to predict them accurately. Earthquake predictions must be reliable and complete, similar to typhoon predictions. We need to know where, when, and how strong will an earthquake be. If a strong earthquake is predicted, say the big one, areas in danger can be evacuated. If we can move to predicting earthquakes years in advance, people can plan where they want to live and where they put up a business better. Urban planners can look into improving city plans to minimize damage. Buildings can also be reinforced to better withstand the shock from an earthquake. The goal of short-range earthquake prediction is to provide people a means of knowing the location and magnitude of a large earthquake that will occur within a short period of time. Efforts to achieve this are being made in countries like the United States, Japan, China, and Russia, which have a high risk of getting hit by a major earthquake. The state of California and United States, for example, has seismologists measuring uplift, the rising of a portion of the Earth's crust, subsidence, the lowering of a portion of the Earth's crust, and strain in the rocks near active faults. Japanese scientists are looking at peculiar behavior among animals that may precede an earthquake. An example of this is what happened in December 1999. Do a search online for Sewell Power Plant, jellyfish, and earthquake, and you'll find news reports of 50 truckloads of jellyfish being fished out of the Sewell Power Plant's cooling system. That caused a massive blackout in the island of Luzon for 2 or 4 hours, and a rumor that jellyfish predicted a magnitude 7.3 earthquake, which happened 2 days later. People living in Mayon volcano have claimed that snakes often come down from the volcano before it erupted. These are just few examples of animals behaving differently that the Japanese are looking into. Measuring earthquakes. Early attempts to establish the intensity of an earthquake relied much on how one person describes it. Intensity is an indication of the destructive effects of an earthquake on a particular place. It is affected by such factors as distance from the epicenter, and the nature of surface materials. This can cause confusion because people's experiences of an earthquake will vary depending on how far they are from the epicenter and the kind of surface they live on. 1902 would give us our first reliable scale of how intense an earthquake is. The modified Mercalli intensity scale was developed by Giuseppe Mercalli and modified by the U.S. Coast and Geodetic Survey. This intensity scale is based on the amount of damage an earthquake does to structures. Another scale for measuring intensity is the Rossi-Forel scale, which had less intensity numbers but still based it on damage to property. This was created in 1873 by Italian Michel Stefano de Rossi and Swiss François-Alphonse Forel. These intensity scales help the government in assessing damage to property. It also helps people like you and me decide how best to respond to an earthquake. Our very own Philippine Institute of Volcanology and Seismology uses its own version of an earthquake intensity scale, which you can find here. These intensity scales, however, were still not reliable enough for seismologists because they never said how strong the earthquake actually is, just how much damage it can do. If an earthquake's amount of damage surpassed either the modified Mercalli or the Rossi-Forel intensity scales, where do they go? Thus, they started to look for ways to determine the total amount of energy released during an earthquake. This measurement is now referred to as magnitude and has given birth to magnitude scales. The one most used today is the moment magnitude scale, which takes into account how rigid a part of the crust is, how much it moved, and how big that area of the crust is. This means there is no theoretical upper limit to the highest magnitude an earthquake can have. Earthquakes with a magnitude of 4.5 and up can already be quite destructive, especially under the right surface conditions. These two measurements often go hand in hand in not only studying earthquakes, but helping plan relief efforts. That was an interesting two-part lesson, wasn't it? Let's now look back at what we learned in part 2 of our module on earthquakes. Faults are narrow zones that separate blocks of crust. They absorb the motion of plates. When there is too much stress on a fault, the fault breaks and an earthquake occurs. Seismology is the study of earthquakes and their effects. The strength and location of an earthquake can be detected from the seismogram, a graphic record of the reading taken by seismograph. Seismic waves are the form of energy in which an earthquake travels. There are two types of seismic waves: body waves and surface waves. The P waves and the S waves are body waves. The focus of an earthquake is the specific spot on the fault which the earthquake originates, while the epicenter is the spot on the Earth's surface that is directly above the focus. The intensity of an earthquake is measured by its effects on a particular location. It is measured on the Mercalli scale and Rossi-Forel scale. The magnitude of an earthquake, on the other hand, is a measure of the amount of energy released during an earthquake. It is measured on the moment magnitude scale. And that's it for our lesson on the types of earthquakes and ways to measure them, Monka learners. I hope you are now enlightened on what causes earthquakes and how they are measured. See you again soon, Monka learners!